Hi everyone. Today we are going to see the topic acids and bases. So what do you mean by acid? It is an hydrogen containing substance that is capable of donating a proton, that is the hydrogen ion, to the another substance. So it is identified by their sour taste, and it basically donate H plus ions, and it can remain energetically favorable after a loss of H plus ions. So for example, there are several acids, that is hydrochloric acid, sulfuric acid, nitric acid. And coming to the bases, it is the molecule or ion where acid lost the H plus ions. Here the H plus ions from an acid, it is accepted. So the bases are the substance that neutralizes the acid. For example, sodium hydroxide and ammonia, calcium hydroxide. So an example is common example is brushing our teeth. So the acid created from the bacteria on our teeth reacts with the base in our toothpaste. So this reaction is normally called as neutralization. And acids are known to turn blue litmus paper into red, and bases are known to turn red litmus paper into blue. So common acids and bases that is found in our daily routines, fruits and vegetables is citrus fruits mainly contains citric acid, and our stomach needs a special lining to protect it from the hydrochloric acid for the digestion of our food. And common food similar with some acid is tomato, vinegar are all acidic. And for example, base, toothpaste is a very good example. And sodium hydroxide is involved in the manufacturing of soap and paper, and sodium hydroxide is manufacture of rayon, and calcium hydroxide is used for bleaching powder. And coming to the acids and bases measurement, a pH meter is a very good instrument to measure the acid and base, and the pH is defined as the minus log H plus ions, that is the negative logarithmic of H plus ion concentration. So acids have the pH below 7 and base have the pH above 7, where pH 7 is said to be neutral. This means that there is the balance of H plus and OH minus ions. And these are the examples commonly we have come across through acid, bases and neutral. And the difference between acid and bases is, as we know, it gives off hydrogen ions, where it give off hydroxyl ions, and litmus paper changing, and it has sour taste, it has bitter taste. And examples also we have seen already, HCl, NaOH. And coming to the theories, there are mainly three theories of acids and bases. First one is Arrhenius theory, Bronsted-Lowry theory, and Lewis definition. So Arrhenius theory, it is in the acid it forms H plus ions, and base it forms OH minus ions. So this is the formula HCl and NaOH, where HCl gives H plus plus Cl minus, NaOH gives Na plus plus OH minus. Where Bronsted-Lowry theory, it is a production of conjugate acid base pair. So conjugate acid base pair where the bases react with the conjugate acid. And Lewis definition, it is the Lewis acid plus Lewis base gives the Lewis acid base in the form of covalent bond, that is electron acceptor and electron donor gives the both in between the covalent bond. And coming to the uses, vinegar, it is and very good acetic acid is used as a food preservative, and citric acid is also the preservation of food, and sulfuric acid is used in batteries in the start engines of automobiles, and the industrial production of dyes, paints, fertilizers are also involve the use of nitric acid and sulfuric acid. And phosphoric acid is used in soft drinks. And uses of bases, already said, NaOH is the manufacture of soap and paper, and calcium hydroxide is used in painting, and magnesium hydroxide is used as laxative, and ammonium hydroxide is used in chemical laboratories. And coming to the properties, it is corrosive, good conductors of electricity, it is sour in taste, and it is a bitter taste. They have soapy structure, and they release the hydroxide ions, OH minus ions. The commonly known examples are the base examples. Thank you.